So basically, what this is describing here is the particle model of matter. So I'm just make a little heading here. Particle model of matter. And what it means is that it's the idea that everything that you see and or breathe or touch, drink, whatever, anything that you've ever come into contact with is either going to be a solid, a liquid, or a gas. So air is a gas, a glass of water, well, water is a liquid, the glass that the water is in is a solid. How do we define whether something is a solid, liquid, or gas? Well, a solid is rigid, so it maintains it's got a fixed shape and a fixed volume. um, the volume doesn't change and the shape doesn't change. A liquid, so if I had the water that's inside the glass, that is not rigid. It flows and yeah, it changes the shape. So it has no fixed shape. So if you pour a load of water into a different shaped glass, it will fill that glass and take the shape of that glass. But it does have a fixed volume. So the amount of water, the amount of space, 3D space it takes up, that is the same. A gas basically doesn't have any of these. It's not rigid. It doesn't have a fixed shape, so it will take the shape of a container, but it also doesn't have a fixed volume, so it spreads out. So we can see here the reason why. So a solid, the reason why it's rigid and has a fixed shape is because the particles in a solid are arranged into a pattern. Okay, and it has a fixed volume, so it cannot be squashed. A liquid, the particles are very, very close together, pretty much touching. They can't really get any closer, and that's why they have a fixed volume. But the particles can flow by one another. They can move around and rearrange themselves. So they don't have a fixed shape, and that's why the whole thing is able to flow. It also cannot be squashed because of the fixed volume. The particles can't get any closer to one another. Gases, well, now the particles are moving around and with a lot more energy, and they are spreading out. So definitely not rigid, no fixed shape again, but now no fixed volume, because I can in theory squash the gas and make the particles get closer to one another. And so yeah, as it says, it can be squashed. So what are these particles? Well, let's imagine we had a block of metal. Let's say this is a block of metal, whatever it might be. Maybe we can say it's a block of iron. Well, iron is made out of iron atoms. So if we looked really, really closely at this block of iron, we would start to see little tiny atoms. Okay. Now we could learn at some point what are atoms made out of, and we could say what are they made out of, and you can keep going closer and closer and closer. But for now, we'll just say that iron are made out of iron atoms. Okay. And they're arranged, because this is a solid, they're arranged in a pattern as we see here. However, if we take another thing, for example, a liquid like water, the water molecules, the water particles. So let's see if I can make a glass of water. So I'm going to, I want to fill it. There we go. That's my glass of water. And again, if we zoomed in on it really, really, really close, we will start to see that these are made out of water particles. Now, so let's just delve into this word. What do I mean by particles for the moment? But yeah, let me label this. So these are iron particles. Iron particles. Particles are basically like a sort of generic word which doesn't give us loads of information, but it's the word that we're going to use at the moment. iron particles, and these are water particles. Now let's get a little bit more advanced. If we look into iron particles, they are, in fact, iron atoms. That is the more official word for them. But in the case of water particles, there's no such thing as a water atom. These are water molecules. And so what's the difference between an atom and a molecule? Have you heard the difference between atom and a molecule before? So basically, everything's made out of atoms. So in fact, let's write a little heading. What is an atom? Well, for now, we can always answer these questions at more depth, but for now, we can say that everything is made out of atoms, which is a bit weird because I just said that water's made out of molecules. Well, molecules are also made out of atoms. So if I were to zoom in now on one of these, no, I know what I'll do. I'll use an arrow here. Let's zoom in on one of these particles, one of these molecules. We see that it is made out of, and I will change the color here, of an oxygen atom. Okay, so that's an oxygen atom, and also 2 hydrogen atoms. So I'm going to make that smaller and white. So, and they're actually arranged like this. You certainly don't need to know the shape that they're arranged, but yeah. So that's a water molecule. Okay, so we can say that a water molecule is made out of one oxygen atom and 2, I'll change the size in a moment, 2 hydrogen atoms. Okay. So each one of these water molecules are made out of this. Now there are many different types of molecules, and there's many different types of atoms. There are a lot more molecules than there are atoms, because the atoms are like the building blocks for everything. So there are about 150 to 200 atoms. But of course, we can rearrange these in many different ways to make different molecules. And some things, as we can see here with the iron, they don't form molecules. They just stay as a big clump of atoms. So the general word which we use in both these cases is the word particles. But later on, you will learn that the word particle is a bit of a simple word to use. So when we talk about the particle model of matter, we're not specializing, we're not specifying whether or not we mean atoms or molecules. We're just simply saying that everything's made out of these little blobs, these little things. Some of these things are atoms, some of them are molecules, and they are arranged in this different way. Before I sign off the video, let's just talk about how do we get from a solid to a liquid to a gas. Well, what we do is we add energy. So if I were to make a little arrow, and then imagine energy, in other words, heat. So heat is a type of energy. So as I add energy to this, the solid can change into a liquid, and the liquid can change into a gas. Now, to be clear here, that doesn't mean that a glass of water has more energy than a block of wood, because it's a different substance. And so different substances are solid and liquid at different temperatures. But if this was the same substance, so water, the solid version of water is ice. And then what do we do to ice to make it a liquid? Well, we melt it. So the process we're talking about there is, okay, let's just try that again. It's not what I want to do. This one. The process to move from a solid to a liquid is called melting. Whereas if I wanted to, let's see if I can find an arrow that goes the other way. Can I find an arrow? Yeah, good. Whereas if I went the other way from a liquid to a solid, so that's reducing the energy, so let's make that blue. We have probably heard that that's called freezing. So what about if we went from a liquid to a gas? That is called not boiling, but evaporation. Or evaporate in this case, we'll say. Okay, so evaporate. Have I spelled that correctly? No, I haven't. Okay. Evaporate. And to go from this is the one that usually people forget, to go from a gas to a liquid, is called condense. It's to condense. So these are the verbs. The noun would be melting, freezing, evaporation, and condensation. Okay. Now you can actually go, one other one I will include is to go from a solid all the way to a gas, and that is called sublimation. Okay. So let's could do with a shape that I can't see a shape that has that. More shapes. Let's see if I can find one that I want an arrow. Okay, I can't really see one. I'll just draw one myself then. So if we went from a solid to a gas, how am I going to draw this? Let's move that down there, and then do that like that. That's called sublimation, or sublime is the verb. Or sublimate. I think let's try sublimate. Sublimate. You don't really need to know all the different words, but sublimate I think is the word there. And there is another word to go from gas to a solid, but I'm not sure what that is. So we'll see. I don't think you'll need to know that much detail. But yeah, so that's a brief introduction to the particle model of matter. Okay.